Hello friends, hope you're doing well. And in the series of data structure and algorithm, today we are going to cover how to rotate array elements. So let's understand the problem and then we'll talk about it. So this is one of the medium problem in you know specified into the programming portals. And the problem is that let's say you're given a integer array, uh, and you need to rotate array by k steps. For example, you got 1, 2, 3, 4, 5, 6, 7, and if you're given k equal to 3, so the output of this should be 5, 6, 7, 1, 2, 3, 4. And how it will go? So you'll do step by step. So first rotate right, you first bring 7 in the first place. You will push rest of the element into the right side, then of course you will get 6, and again you push it and you will get a 5, and then again you push. So basically you are going to do this 3 times. Same, another example could be if you have -1, -100, 399, 2 times. So first you will bring 99 front, you will push rest of element in the right side, same thing, and you will do 3, and they will push again. So this is how you're going to, this is a problem statement, right? So you need to do this in a fastest way possible. Okay, so let's look into the approaches that we have at this point. Again, the first rudimentary approach goes with the nested loops up to NO2, and it goes like you got to have 2 loops, and it's kind of does that. We're going to look into that as well. And then followed by the efficient approach, that is kind of, instead of having a nested loop, it has a parallel loop, but still the time complexity remains O(n). So it's much better and cleaner approach. So let's jump into the coding. Let's see how to do that, and let's start coding and see that how to go about it. Okay, so as always, if you follow my video, you will understand that we create a class driver. Sorry, class is there, but you will create a, oh yeah, let's create a class as well. So class, let's say make it internal class. Let's make it maybe temp, and then in that we'll create a method driver as we're doing in the previous videos to make it simpler. So basically, it is getting called from you can say from main. So it is getting called. So public static void driver. Now, basically, you got to write a code that will fetch the data. Basically, it will do 2 things. It will ask rotation type and number of rotation steps that you need to perform. Okay. So to save the time, what I'm going to do is I'm going to get it. I have got feedback from previous video that videos are getting longer, so I'm going to keep a not so core logic maybe handy so that we can save some time. So I'm going to bring that code, and just give me a moment. Yeah, so this code will basically ask you to enter the rotation type and steps. Simple code. It will ask basically your L or left rotation, right rotation, and of course how many steps you want. So these 2 data will be basically will be there with you. And the other, I would say, regular code is that we yeah. So basically we're going to have a 2 method, rotate left and rotate right. So first we're going to go with a rudimentary approach. So again, basically to save time, I'm going to get this code, and it is about, let's say, you rotation type is equal to left, you want to rotate left, so you will call it left, and if it is right, you will call, this will be called simple, right? Now let's look into the rotate left and rotate right, uh, if you remember, we talked about brute force, uh, you know, methods to begin with. So let's write that. So that is the main method for that. So that's where we're going to write it together. So private static void, and what's the name? Rotate left. It's a private name, so the r is we have kept small just to follow the convention. And we're going to have int array. Let's give name nums and steps int k. Okay. So yeah. So basically, yeah. So this is this, and now in a rudimentary approach, you just want to get the job done, right? You hardly care about performance because you want to get something done. So let's get started. So we'll create a loop, and as you can sense, it goes till like k steps because uh, k is the steps on number of time you need to do that. So with that, we are going to start from 0 and go till get k. Now if you notice or if you think how we can achieve with rudimentary this right rotation. So basically what we can do is we can take the last element in the, for example, if you go back our deck, last element here is, let's say, 7. So you're going to store 7 into some temp variable, and you're going to move step by step all the elements basically. So you are going to push the element, uh, you know, so in left, you're going to, uh, you are rotating left. So you will take, instead of last, you will take the first one. And because we are going to rotate left, so if you don't keep the first one, your number will be like gone and you don't have the data. So first, for example, 1 you will store, and then what you will do, you're going to rotate again. You'll have another loop that will push elements from right side to the left side. So for example, k plus 1 will be stored into k. So basically, if you notice, numbers are coming towards left, right? That's the thing. And in the end, what you will do, if you remember, you store the first element into some temp variable, and that number you will store in the last. So that way you're taking care about first and last element using some temp variable, and rest of the element will be done with a loop. Okay, and how that loop will work, we will see. We are saying that. Okay. So for that, so let us store, so int temp. So we're going to store the first element into this. Okay. Or we can do one more thing. Instead of doing both in the interest of time, we can rotate just one, and you can follow the other yourself, because it is pretty similar, right? If you know one, you can do other. So what we can do is stop, because the question we asked for right. So what we can do is, let's implement right, and you can follow the, I would say, how this is done, and you can do it. It's not that hard. So yeah, let's focus on right, and so that we can complete end to end. So instead of here again, I was telling that you will take, instead of first, you will take the last element, and last element is going to be not 0, but you're going to be there num of, basically here nums dot length minus 1. Okay, this is the last element. Now again, in rudimentary, what you will do is, just you want something to get done, so you will start another loop. Let's say int j equal to, basically you're trying to rotate right now, correct? So you're basically moving elements into the right side. So if it is j, you will put j into, you will replace j with j minus 1, like that. So j equal to, you will start with, since you are moving, so you will start from, I would say from last. So j equal to nums dot length minus 1. You will go until j equal to, not equal to 0, but j greater than 0, because you've taken care about the first element already, and I will replace later. And you will do j minus minus. Okay. And let's see. So the trick here is, okay, there is one brace missing. That's fine. Yeah, so with that, let's do the real magic. So what happens that j you will replace with the previous element, as you can see. So basically, if your previous element is replaced with this one, then you are rotating writing. So you go start from last, and you'll keep replacing until zeroth element, because zeroth element you are handling is differently. And how is that differently? Because you stored, you're replacing the last element with the first one, right? So what you will do nums of 0 with what you already stored. Okay, so what is stored? Temp. So you'll replace with temp. So like that, you will go 3 times. So first time, you will replace, and then second and third. So by which you can get what you're supposed to get, or number will be replaced or rotated, like moved into right side k times, right? And then after that, you will save as well, or rather you will print into that. So let's see that, you need to print as well to them. So with that, let's run this and see whether numbers are indeed getting rotated or not. So you call that this is array is not resolving. Okay. We need to also ask users to add the array element so that it can store it. And to ask again, we have code snippet. It's pretty simple. We can check that. So basically, after getting user rotation type and steps, you will ask that, okay, we'll ask them to enter the array elements, right? Using link, you can store into this array. Okay, now let's see. Now let's try to run this. So test.driver, not test. Oh yeah, test, not temp, test. It should resolve now. Okay, now let's run and see if it is working. So we can take the same example as we looked into deck. So we are rotating right, and let's say 3, and we can enter element like 1, 2, 3, 4, 5, 6, 7. And you can see the 5 is coming, then 6 and 7. So basically three step right rotation already happened. So this looks good, and you can also validate this with this. So 5, 6, 7, 1, 2, 3, 4. So it is working basically, but it's not efficient, as you notice. It's not efficient, right? So for that, yeah, it's not efficient, and hence we need to make sure that also, so because it is happening in O and 2, and it's not efficient. So to make it O and, let's refine it. So what we can do is we can keep this, and we can get another copy of this. We can make it rotate right 2, okay, and maybe we can change this calling as well. Okay, and for that, okay, as I was saying, if you remember that we can get it done with 2 parallel loops. So again, for that, what we need to do, let's clean this out. It's not required. So we can create a integer array to begin with, because it will have little more space complexity, but I think time complexity takes precedence. So yeah, and size would be of this array nums dot length. So we're getting a basically replica of that, you can say, nums to begin with, and we'll have a 2-point counter approach. 2-pointer, you can say, it's more popular word, 2-pointer approach. So this is a 1-pointer count, right? It will keep moving and apart from the loop. So and then we'll start. So we are starting like for int. So I will start from how many steps we want, right? So for I equal to k steps we want. So we're starting from k. It will go till I plus plus, typical coding that we do. And what we're going to do is we're going to have this array will store into that this element, the first element, and then we're going to increase counter for next. So this is how we are going to store this from k till this. So basically from we want to rotate from these 3 elements. So from this position we are going to have things stored or values stored into this variable, this array. Okay. It is done creatively to, I would say, to do efficiently the same thing. You will achieve the same thing, but in a smart way. And one more loop we need. That loop will basically start from 0, and it will go a less than k, because this will go from start from 0, and basically it is coming like one less than a less you can say one less index than this one, right? And then again you're doing the same thing, so no magic here. You're doing basically from k to there is getting stored, and from 0 you're going, again you're doing the same thing. So indirectly you are rotating, right? And we'll see that how this works, and it is much more efficient. So using this pattern you can do that. And since you have done things into result array, or you have manipulated data into result, you also need to copy this, because you're supposed to do this in place. So copy to nums. So data will be copied to replace to the nums. Nums is the original array, and then you're going to print this. So using this smart approach, you can efficient approach, you can rotate the elements by k steps. And let's see how this works. So we'll do the same, but it is much more efficient because just O and here. And let's see. So again R and 3, 1, 2, 3, 4, 5, 6, 7. Okay. There is like a little bit somewhere. It should be 5, because it should be. Okay, let's see where is a small mistake I think we have done. Okay, so new nums dot length count equal to 0, I from equal to k, length. Okay, nums I equal to 0 starting from k, I plus plus, nums I. Okay, nums 0. Let's see over here. Okay, so we are getting L and R from users, then we are getting steps, and then we are getting users, the array elements, and it is R. We are going over here. It should 5 should come first. Okay, I see. So yeah, so we have basically what I would say, shuffle the logic. It should be starting from end, not from begin, right? So let me make a quick correction over here. So look at this, right? So we are starting from basically last and So just a reverse, right? So now you basically looked into the left rotation. For right, what we need to do, you start from last element basically, and length how much there, and how much is step. So we'll do minus and start from there, and the same thing. And for that, from other side, for the remaining, we'll start from 0 and we'll go length minus k. This is an additional logic we have to do for right rotation. The previous one that we looked into was for left rotation, but I think you also, in a way, you understood the left as well. And rest remains the same. So that's the catchy part there. Now let's run. So R3, 1, 2, 3, 4, 5, 6, 7, and here we go. So 5, 6, 7 followed by this. So if you notice this, right, the logic is getting clearer. So you're starting from 5, 6, 7 in a first loop. Other loop you're starting from 1, 2, 3, 4. So using this, creative approach, we are able to rotate elements because the end result is same and we are doing is efficiently. So that's what matters, right? How you do efficiently. So by which we could achieve this. We look into the first rudimentary approach, where O and 2 complexity, and then we look into the smart approach. Okay, and I expect you to take care about left rotation yourself, and then put into comment section for any challenge that you may have. Now let's wrap this. So we looked into this. Code is available over here as well in case you want to follow more. We'll put a left rotation code as well for your reference. And thanks to this platform who help us give a good challenging questions. I really appreciate that their work. And it's a bit about me. I do this out of passion, apart from outside my day job. Okay, so I also add those videos over here. So in case you want to don't miss next one, you want to subscribe. And with that, thanks for your time.